Hi guys, this is PV Rajunit. I'm here today to give a brief presentation on RTN codes for COC, Computer Organization and Architecture. Um, this is the basic symbols for RTN. Like this symbol indicates for register on LHS stores the value from RHS. This is the word index, selects word or range from a named memory. This is bit index, selects bit or bit range from named memory. Index range from left index n to right index m can be decreasing. This if then true condition of on the left value or action on right. This is definition, text substitution with dummy variables. This is concatenation, bits or right happen on the bits. Then these are all the some other basic symbols of RTN which will be helpful for us to understand RTN in a very good and brief manner. And next, before we can go to next slide. This is we will discuss now about control unit, microprogrammed and hardwired. This is the functional requirement of a processor. This is the operations and opcodes. This is the addressing modes, registers, IO module interface, memory module interface, interrupts, and these two will be coming under the instruction set column, and these two will coming under the system bus column, and system bus and OS will be coming under interrupts. The execution of an instruction involves the execution of a sequence of substeps generally called cycles. The control unit of a processor performs mainly two tasks. Which two tasks? Like it causes the processor to step through a series of micro operations in the processor's proper sequence. Like it will follow some proper sequence to be get done based on the program being executed, and it generates the control signals that cause each operation to be executed. This is the program execution constituent elements. Like this will be in the form of chain. Like this is called as networking cycle. Like program execution, there will be from program execution there will be 4 trees where 4 instruction cycles will be there, and from every instruction cycle there will be fetch, indirect, execute, interrupt, and from fetch there will be UOP, and then the procedure follows as soon. The performance of each subcycle involves one or more shorter operations, that is micro operations. Micro operations are functional or atomic operations of a processor. Okay. This is fetch cycle. Fetch cycle occurs at the beginning of each instruction cycle and causes an instruction to be fetched from the memory. Okay, from the memory. 4 registers are involved. These are the main registers. Like we want to have a look about this, and this is MAR, MBR, PC, and IR. This MAR and MBR, we'll look on that further. See, now we got MAR means is memory address register is connected to address lines of the system bus. It specifies the address in the memory for a read or write operation. Okay, for a read or write operation. Memory buffer register is connected to the data lines of the system bus. It contains the value to be stored in the memory or the last value for read, last value read for the memory. Okay, read from the memory. Okay, sorry. Program counter holds the address of the next instruction to be fetched. Program counter it will holds the address of the next instruction to be fetched. Okay. Instruction register holds the last instruction fetched. See, this is very much similar to the program counter. This is the next instruction, and this is the last instruction to be fetched. This is the sequence of events in fetch cycle. Like initially it will be beginning before T1, and this will be like in this form of program counter. The memory will be stored, and after the first step, memory address will be stored in memory address register, and in the second step it will be coming into the memory buffer register by moving 3 bits forward, and then after third step, and it will occur in this instruction register also, and this will be like this. Okay. Micro operation of fetch cycle. Like this will be very similar to the RTN codes what we have learned earlier. Like in the step T1, memory from the program counter address files will be saved to the memory address register, and then in memory buffer register memory will be stored, and in program counter plus I instruction, which I is the instruction length. Each clock cycle defines time unit, all equal duration. Okay. T3 IR memory buffer register will be stored, address of the memory buffer register will be stored to instruction register. first time unit, move contents from of PC to MER. This is the explanation of the RTN code which I explained earlier. Okay, I am skipping that. Okay, grouping followed two rules. Grouping will be following two rules. The proper sequence of the events must be followed. Conflicts must be avoided. One should not attempt to read and write from the same register in one time unit because the results would be unpredictable. Okay, avoid duplication of circuitry. Micro operation of indirect cycle. Once an instruction is fetched, the next step is to fetch source operands. Consider one address instruction format. Direct and indirect addressing. T1 IR address will be stored to memory address register, and then memory will be stored to memory buffer register, as I said earlier. And now this is called indirect addressing mode. Indirect addressing variable, using indirect addressing variable, and this is the same by using direct addressing mode code. And this is the execute cycle. Fetch, indirect and interrupt cycles are simple and predictable. Each involves a small fixed sequence of micro operations, and in each case the same micro operations are repeated each time around. This is not true of the execute cycle. Variety of opcodes. Example, this is RTN code for addition. This is also a simple example for increment and skip if 0. Like if it is 1, then we'll add 1. If it is 0, then we no need to add anything. Instruction cycle. Each phase of instruction cycle can be decomposed into sequence of two elementary operations. Assume a new 2-bit register called the instruction cycle code designed at the state of processor time. Like 0 0 will be fetch, and 0 1 will be indirect, and 1 0 will execute, and 1 1 will be interrupt. This is the flowchart for instruction cycle, where this is the ICC, and for 1 0 it will execute, like it will flow like this, and it will come like this. Or for 1 0 1 it will read address, and ICC will be 1 0, and then it come again and it will process again to this. And if it is 1 0 0, it will fetch, and fetch instruction will be called, and then indirect addressing ICC equal to 1 0 1 0 1, then setup interrupt, and ICC will be 0, and then what and why micro operations. The behavior of a processor is decomposed into elementary operations called micro operations, able to define the functional requirements for the control unit. Characterization of the control unit. Define the basic elements of the processor. Describe the micro operations that the processor performs. Determine the functions that the control unit must perform to cause the micro operations to be performed. Functional requirement. All micro operations fall into one of the following categories: transfer data from one register to another register, transfer data from register to an external interface, and transfer the data from an external interface to a register. Perform an arithmetic or logic operation using registers for input and output. What is control unit doing? Control unit performs two basic tasks: sequencing and execution. The control unit causes the processor to step through a series of micro operations in a proper sequence based on the program being executed. And execution, the control unit causes each micro operation to be performed. Okay, control unit model. This is the basic control unit model. This is the control unit block diagram, and this is the control bus, and where it will receive the input signals from as we all know, control unit is a main part of the CPU. Control signals within CPU will be coming here, and instruction register will be coming from here. And this is the control signals from control bus, and this is control signals to control bus. Inputs to control unit. Clock. The control unit causes one micro operations to perform for each clock pulse. Processor clock cycle time or the clock cycle time. The opcode and addressing mode for the current instruction are used to determine which micro operations to perform during the execute cycle. Output from the CPU. There are two control signals within the CPU. There are two types: those that cause the data to be moved from one register to another register, and those that activate specific ALU functions. Control signals to control bus. These are also of two types: control signals to memory and control signals to IO modules. This is the data path of control signals. This is not required much. And this is the RTN. This is the RTN code for for addition. This is in the fetch cycle, as I said earlier, this will be happening, and in the indirect addressing mode, as I said, we use the indirect variable, like here in case of IR address, and interrupt, we have discussed this earlier also, and this is the block diagram. As I said, it is not required for us. This is hardwired control unit, like in this 1000 execute and interrupt. This is also we have discussed earlier, and just we have to recover it again. um, Hardwired control unit. The cycles or phrases are constructed as a state machine. The individual instruction executions can be constructed as state machines. One ALU is implemented, all instructions share. Okay. Problems with hardwired control unit. Sequencing and micro operation logic gets complex. Difficult to design, prototype, and test. Resultant design is inflexible and difficult to build upon. Adding new instruction require major design and adds complexity quickly. Hardwired and microprogrammed control units. In hardwired control units, control signals are generated by a micro instructions are used to cause registers and ALU operations. In microprogrammed control unit, the control unit is specified by microprogram. And this and all are basic idea. This is the single address field, and this is the two address fields. And I end my lecture by this. Thank you very much. రే ఆపరా బాబు దీన్ని. రే రికార్డ్ అయిపోతుందా ఇది కూడా?
సరే